All right, the next, I think I start every single one of these as all right or okay. Probably did the same in lessons. This one is from 1980. I was not born, neither were you. Same as the first one. We have a graph of the derivative. It's nice they say, note, this is the graph of the derivative, not the graph of f, and a bunch of information. First, we want to find all values of x for which f assumes a relative maximum. Okay, well, relative maxima, plural maximums, occur when f prime goes from positive to negative. So looking at the graph, the derivative is positive all along here, and then crosses, goes from positive to negative, crosses the x-axis at 2. So this occurs at x equals 2. So f must have a relative maximum at x equals 2. Part B, absolute minimum. Okay, so it looks like f is increasing from -1 to 2. So f is increasing from -1 to 2 since the derivative is positive, and decreasing from 2 to 4 because the derivative is positive over here and negative over here, decreasing from 2 to 4. Similarly to the prior problem, the absolute minimum must therefore occur at an endpoint. So either x equals -1 because it starts increasing from there, f starts increasing, or at 4 because it stops decreasing there. So at an endpoint, x equals -1 or x equals 4. Okay, conveniently, f of -1 we know is -1, and f of 4 is 1. Since f of -1 is less than f of 4, because -1 is smaller than 1, the absolute minimum occurs at x equals -1. Again, looking at the question, we want to find all the values of x. That's what we were looking for. In this case, both answers, the x and the y, are -1, but good to check just to be safe. Part C, we're looking for when f is concave downward. So f is concave down on the intervals where the rate of change of f prime is negative. Basically the slope of the tangent line the derivative of f prime, or where f prime is decreasing. This is where the second derivative is less than 0. So let's see where this occurs. F prime is decreasing, kind of going downhill from -1 to 0, and from 1 to 3. So this occurs on the intervals -1 to 0, like we just pointed out, and 1 to 3. So again, it's where it's going downward. The values of f prime are decreasing. Part D, we're looking for points of inflection. And these occur where f double prime of x changes sign. Usually we're looking for where it equals 0, but really it doesn't matter if it's 0, it has to change sign, which I guess only occurs when it's 0. But so let's make ourselves a little table. X, f double prime, let's see. So the slope of the tangent line of our graph, or the slope of the tangent line of f of x is 0 at 0, 1, and 3. And we'll have to look around there. So let's do 0, 1, 3. If we look at the slope of the tangent line of this graph, or f double prime, to the left of 0, so right in here, slope of the tangent line is negative because it's decreasing. Between 0 and 1, increasing, so positive. Between 1 and 3, it's decreasing, so negative, and then it's increasing again, so positive. So since f double prime changes sign at all 3 of these locations, f has points of inflection at x equals 0, x equals 1, and x equals 3. Part E, sketching the graph. Trickiest part for me, my graphs are real bad. All right, so let's make a coordinate plane. So we're going from -1, and we have 0, 1, 2, 3, 4. Let's see what we know. F of -1 is -1. F of 0 is 0. And f of 4, take a mark here, is 1. So those are the points we have. And now what we know, it looks like the slope of the tangent line, or the derivative, is positive from -1 to 2, so f will be increasing. So we get to 2, and then it'll be decreasing until it gets to 4, which is just when it ends. So that's close enough. It might look a little bit different, but that is good enough to get your points.